Okay, so we're going to start talking about angles in standard position. So we're doing this to start to extend our understanding of sine and cosine so that we can take the sine and cosine and tangent of angles that are greater than 90 degrees. Okay, so we're just going to get down a little vocabulary. And the convention for when we talk about these angles is that we always start, if you remember the in-class material we looked at, we had Paul starting at the point 1, 0. Okay, so similarly, we're going to have, that's not the color. Okay, when we talk about angles in standard position, the idea is we always have our initial ray. So remember, a ray is it's like a line that has starts at one point and goes on forever in one direction. So this is a ray. We always start there when we talk about angles in standard position. So this ray here, we're going to call that the initial side. Of the angle. Okay, that's the initial side of the angle. And then what we do is we rotate counterclockwise. So we always rotate counterclockwise and we land somewhere. Oops. Okay, and we've rotated an angle, so we'll call it something. We'll call it theta. Okay, and where we end is called the terminal side of the angle. So this is the terminal side. So you'll want to know these terms just if they show up in problems, as they will soon. This is the terminal side of the angle. Okay, now when you rotate counterclockwise the way we did, that's a positive angle. So positive angle when you rotate counterclockwise. All right, now if we go over here and rotate clockwise, that would be a negative angle. So let's say our initial ray is there, again, always on the positive x-axis. It's a little uneven, but there. And if we rotate clockwise, then that is a negative angle. Okay, so there's my terminal ray. So that's a negative angle, and we'll just call it something else. We'll use the Greek letter alpha. Okay, so negative angles, you rotate is when you rotate clockwise. Okay, and so those are sort of like the rules of the game. And two angles with the same terminal sides are called coterminal. Okay, so two angles with the same terminal sides are called coterminal. So for example, if I give you, so I'll do a quick example here. For example, if I give you, well, if I say, if I talk about 60 degree, whoops, if I have 60 degrees, 420 degrees, and negative 300 degrees, those are coterminal. And the reason is, if we sketch them, they all have the same terminal sides. See, watch. So if I rotate 60 degrees, that means I start, again, I always start the positive x-axis and I rotate 60 degrees and I'll land about there. That's 60 degrees. There's our rotation. If I rotate 420 degrees, well, I start here. Let's say I rotate all the way around once, that's 360, plus an extra 60 gets me to 420. So if I rotate in that fashion, notice I'm in the same place as I was with the 60 degree angle. Whoops, I'm going to write that as 420. And same here, if I rotate negative 300 degrees, well, that's like rotating all the way around except for that last 60 part in the negative direction. So this is rotating, since I went clockwise, I rotated negative 300 degrees. They're all coterminal because they all share the same terminal side. All right, so these are just some conventions. Let's look at one quick example, and then we should be set. So this says find and draw a positive angle and a negative angle that are coterminal with the given angle. So 30 degrees. Let's find an angle that's coterminal with 30 degrees, a positive and a negative. Where are my straight lines? There they are. Okay, so we know where 30 degrees is. 30 degrees is right here. Positive 30 degrees is roughly there. And so let's draw one that's coterminal, that's positive. Well, I can go to the 30 and then go another 360 and I'll land there. So 390 degrees works. Basically just add 360. And in the negative direction, I could go, see, I could start here, go in the negative direction all the way around, except for that last 30 part to get back here. So I went negative 330 degrees. So 390 and negative 330 degrees are coterminal. And again, really all you need to think about is if you add 360 degrees to this or subtract 360 degrees from that, you'll get a coterminal angle. And in radians, of course, pi over 4 we know is radians is equal to amounts to rotating 45 degrees. So there's pi over 4. All right, so again, we're in radians, so we got to put our answers in radians. That's pi over 4 radians. And what's nice about 45 degree angles is you can just count on the picture, because 45 degrees is pi over 4. So this is 1 pi over 4, that's 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. So if I were to do that rotation, that would be 9 pi over 4. 9 pi over 4. And if I go, I can go in the negative direction too. I can go negative 1 pi over 4, 2 pi over 4, 3 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Nope, that can't be right. Negative 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. There we go. So that's negative 7 pi over 4. Okay, so there we have our basic definitions. I think this is relatively familiar to most of you anyway. Just and bear in mind that if you wanted coterminal angles with pi over 4, in degrees you'd add 360. In radians you'd have to add 2 pi. And the issue with adding 2 pi to pi over 4 is you have to write 2 pi. You'd have to write it as you want a common denominator because pi over 4 is a fraction. 8 pi over 4. And notice 1 pi plus 8 pi gives you 9 pi over 4. So that sort of confirms that answer there.